Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations. Today, we're talking about the inner lives of AI. We ask them questions all the time, but can they tell us how they're thinking?
Exactly. It's a huge question. When you ask a language model to explain its reasoning, is it giving you a true account of its internal process, or is it just telling you a plausible-sounding story that it cooked up after the fact?
It feels like it should know, but a new paper from Emilio Ferrara at the University of Southern California decided to put this to the test. It's called Open-Weight Masked Introspection, measuring what language models can report about their own computation.
That's a mouthful, but the idea behind it is brilliant. The researchers wanted to know if you mess with an AI's internal thought process, does it notice, and can it tell you about it?
So how on earth do you test that? You can't just ask it, hey, are you feeling okay?
Right, you have to be more clever. They developed a framework they call OWMI, which stands for Open Weight Masked Introspection. The process is pretty simple in concept. First, they give an AI a normal task.
Like a math problem or a trivia question.
Exactly. But while the AI is in the middle of thinking about the answer, the researchers perform a kind of digital brain surgery. They go in and subtly alter one of the internal calculations the model is making.
So they're basically poking its virtual brain while it's trying to work.
That's a perfect way to put it. And after the poke, they ask the model a very simple question. Did anything in your own computation just change, yes or no?
Okay, that seems straightforward, but I feel like an AI might just say yes to be helpful, even if it didn't notice anything.
And that's why this study is so good. They built in controls to prevent that. The most important one was what they called a sham run. This is where they did the whole process, gave the model a task, interrupted it, but they didn't actually change anything. They just pretended to.
Ah, a placebo for AIs. So if the model says, yes, something changed during a sham run, you know it's just guessing or making things up.
Precisely. They also had other controls, like poking the model in a random way, just to see if it was reacting to general disruption versus a specific targeted change. They covered all their bases.
So they ran this experiment, poking the AI, asking if it noticed, and using these sham runs to keep it honest. What did they find?
This is the core result, and it's pretty stunning. They ran over 78,000 measurements across 8 different AI models from 7 different developers, and in almost all cases, the models were no better than a coin flip at telling whether they'd been interfered with.
A coin flip? So completely random?
Essentially, yes. The scientific measure they use is called AUROC, where a score of 1.0 is perfect detection and a score of 0.5 is pure chance. The models scored around 0.5007. That is statistically indistinguishable from random guessing.
Wow, so current AIs have basically no reliable self-awareness of their own thought process. They can't tell you what's happening inside their own heads.
That's what it seems, but then the paper delivers a massive twist. This is the part that really makes you think. The researchers wondered, okay, maybe the model can't report the change, but is the information about the change still in there somewhere?
How would they check that?
Instead of asking the model, they used other tools, what are called linear probes, to look directly at the model's internal state, its activations during the experiment. And what they found was that the information was there, clear as day.
Wait, so the AI knew on some level that something had been changed. It just couldn't say it?
That's exactly what the evidence suggests. The information was present and easily detectable by an external tool with up to 95% accuracy, but the model itself couldn't access that information and turn it into a verbal report. There's a disconnect. The path from its internal state to its verbal output is broken.
That's fascinating. It's like when you have a word on the tip of your tongue. You know it, you can feel it, but you just can't say it.
It's a great analogy. And there was one other weird finding that supports this. One of the models they tested always answered no, nothing changed to the question, every single time.
So it was completely useless at detection.
In its words, yes, but the researchers looked at the confidence score the model attached to its no, and they found that the model was significantly less confident in its answer when it had been interfered with.
So the truth was leaking out, not in the words it said, but in how sure it was about those words.
Exactly. The signal was there, just in a different channel. The model was, in a way, subconsciously telling them that something was off.
So what's the big takeaway here for all of us who use AI every day?
The big takeaway is that we should be very cautious about trusting an AI's own explanation of its behavior. When you ask it to show its work or use chain of thought reasoning, the explanation it gives you might just be a plausible story it generated to satisfy your prompt, not a factual account of what actually happened under the hood.
Which means for serious oversight, like making sure an AI is safe and reliable, you can't just ask it if it's behaving properly.
That's the author's main point. Oversight practices that rely on the model's own testimony need to be validated. We can't just take the AI's word for it. Instead, we need tools that can look directly at its internal state, its activations, to see what's really going on.
So the debate isn't settled, but this paper gives us a powerful instrument to actually measure this ability, this introspection, as models get more and more advanced in the future.
That's right. It's not just a finding, it's a toolkit for the future of AI safety and interpretability.
A fascinating look into the silent inner world of AI. That's all the time we have for today. Thanks for tuning in to Daily Papers.